Hello everyone, welcome to another Python Pandas related tutorial on our channel. This is a Python Pandas project where we are trying to do analysis of water quality. So in this project you will learn how to do or how to determine water samples as potable or non-potable, that means safe for drinking or not drinking. We will create some simple charts like a pie chart. You will understand how to create the correlation matrix, how to create this distribution plot, where on the basis of different parameters that we have in the dataset like pH value, hardness, solids, chloramine, sulfates, conductivity, etc. What is their distribution for potable and non-potable water samples? So let's get started and I will explain each line of code that is used here. So the data set that we are going to use in this water quality analysis is this data set on Kaggle. In the data set we have different parameters, that is pH of water, capacity of water to precipitate soap in milligram per liter, total dissolved solids in parts per million, amount of chloramines in part per million, and similarly we have these other columns. In the dataset it is very important that the target field is potability, which indicates if water is safe for human consumption. We also have turbidity, measure of light emitting property of water in NTU, and amount of trihalomethanes in microgram per liter, amount of organic carbon in parts per million, electrical conductivity of water, and so on. So from here you can download the data set. I will provide you the link. After downloading the data set, we are opening Google Colab here. We have opened Google Colab here, and in Google Colab simply we will upload the data to session storage. Remember, next time also when you have to continue this, you have to do the same thing. So let's upload the CSV file that we have downloaded from here. So in Google Colab, select it. If you are using Jupyter Notebook, then you can skip this step and just put the file in the same folder. You can just put the file in the same folder as your project and do it. Now when it will be loaded, we can copy the path. We will import pandas spd because this library will be used for data processing, and we will say df is equal to pd dot read underscore csv because the file is in csv, and the path that we copied, we will simply put it here. We will write df dot head, and just to see if we are getting all the columns, all the values properly here. This portability, if it is 0, that means the water is not that's for this sample. Every row represents a water sample. 0 means it is not potable, 1 means it is potable. So for that, if you will write df dot potability dot value underscore counts, so you will get information of how many samples are drinkable, that water is suitable for drinking, and in how many samples it is not. And the purpose of this analysis is to find out the effect of these different parameters on the potability of water. So let's get started with that. If you want to read information about these different parameters, their effect, so the great content is given here. Total dissolved solids, which is often calculated to find out water quality. Even when you will install RO in your homes, then the technician that comes measures this chloramines, sulfate, etc. So you can find out. Now First thing that we can do here, let's say on the basis of this, we can create a very simple pie chart. We can dot plot kind is equal to pi, and we can write auto PCT is equal to percentage point to F. This will give us a simple graph that in 60.99 cases, almost 61% cases, water was found not potable. So on the basis of potability value 0, we can see 61% of cases are not potable. So this project will be in several parts, and in this project you will learn bivariate and multivariate data analysis, correlation analysis, pre-processing, missing value, train test split and normalization, modeling, that is decision tree and random forest classifiers, and visualize decision tree as well. Then random forest hyperparameter tuning. So in the first part we will do exploratory analysis, basic exploratory analysis to understand how different parameters are affecting the potability. For the projects, the libraries that we will need, these are machine for ML and model training. The libraries that we have is decision tree classifier from tree. So from scikit-learn.tree we will import decision tree classifier. From sklearn.ensemble we will import random forest classifier. From model selection we will import randomized search CV, repeated stratified k-fold and train test split. From Sklearn metrics we will import precision score and confusion metrics, and from Sklearn we will import tree. Next, this is optional. If you want to ignore warnings, you can just do it, because we don't want our notebook to show warnings. Let's use the info method. So this info method will help us in understanding that we have 3276 entries, where in pH we have 2785 non-null, hardness, solids, chloroamines, we have all values. So this helps us in finding out in which columns we have missing values. For example, here we have a missing value. Here we can see some missing values which are given as NaN, which is not a number. To further understand the data and distribution of values, we can write df.describe. This describe method will take all the numerical columns that we have, like pH, hardness, solid, etc., and it will give you their mean value. You can see mean pH is 7.08. So this is a range above or below which water is either acidic or basic. So if you will just go simply, a pH of 7 indicates a neutral solution, neither acidic nor basic. So on an average we can see the pH value is 7, but minimum value is 0 and maximum value is 14. So you can see we have samples of different types, both acidic and basic. So similarly you can see for other parameters as well, and you can do some research about finding out what is the average value of chloroamines, lower value means, what higher value means. Next we will also do dependent variable analysis. Now for plotting graphs and visualizing data, we will use NumPy for linear algebra. We will import Seaborn as SNS, and we will import matplotlib.pyplot as PLT. So we will do simple correlation between features. To find out correlation between different features and target field that we have, we can write df.corr, the correlation method. Here you can see we have pH, hardness, solid, etc. This is potability. You can see some of them have negative values here and some of them have positive values. So first of all, to visualize this, we can create a cluster map. So using the Seaborn library, the Seaborn as SNS, we have a cluster map where we will put df.corr as our data. Then we will use CMap as VLAG. Then we will use dendrogram ratio 0.1.2, FMT 0.2f. We will use a naught is equal to true, line width is equal to 0.8, and figure size is equal to this. Don't worry, I will just explain you meaning of these parameters as well. First of all, we will see what kind of plot it will give us. This is basically the same plot, but we can see for what values. You can see some dark values here, for example sulfate and hardness. If you see portability, in portability you can see, for example, the organic carbon. Then you can also see the impact of trihalomethanes, etc. So you can see the correlation between these values, and on the basis of positive and negative values you can see whether it's a strong correlation or a weak correlation or inverse uh, indirect relationship. Now let's understand the meaning of these different parameters. So parameters df.corr, this computes the correlation matrix. CMap is equal to VLAG, sets the color map. VLAG is diverging color map, that is good for showing positive versus negative correlations with 0 in the center, white, red for positive or blue for negative. You can do that. Dendrogram ratio controls the proportion of figure used for row and column dendrograms. Point 1 means 10% of the figure height is used for row dendrogram, and point 2 which means 20% of the figure width is used for column dendrogram. FMT.2f formatting is style for the annotation text. The value shown in the heat map, that means values will be shown with 2 decimal places that you can see here. Annotation is equal to true, annotates the heat map with actual values in each cell from correlation metric, not just the color. Line width 0.8 sets the width of the line. So this way, this is the meaning of a cluster map, and you can see it here, and you can see which parameters have more effect on our target field and which parameters have correlations with each other as well. So from the output we can say there is not much correlation, meaning that every data affects some amount. Now next we will see the distribution of features. So we will say non-portable is case where in DF if we query portability equals 0, that means select all the data where portability is 0, and we will call portable as obviously portability equal 1, that means this is a comparison operator. Then we will use a figure size of 15 by 15. We will create subplots for axis comma column in enumerate df.column, that means get the index ax and column name col. So we will use all the columns from 0 to 9. We will use plt.subplot. We will axis starts from 0, so we will add 1 to number the subplots. So this will be axis plus 1. We will set the title of each subplot as the column name, title, column name. Then we are creating a KDE plot, KDE for non-potable water and KDE for potable water. KDE plot is just like a distribution plot with a curve. So where you are using x is equal to non-potable and we are using column labeling as non-potable. Then we will use legend. We will show legend that will show what is the meaning of different colors, and then we will just adjust the spacing between plot to avoid overlap. So let's create this and let's get our chart. So here you can see a 15 by 15 chart is prepared, and here you can see, for example, in pH, you can see the distribution of pH for non-potable and potable water samples. Similarly, so you can see in case of in both cases, number of samples for potable are more in the range 6 to 8. You can see here, right? Similarly, for hardness, in case of water hardness, you can see more samples in the range of water hardness value around 200. Similarly, you can see it for solids, total dissolved solids in the water, chloroamines, sulfate, you can see for conductivity. So in one go, for turbidity we can see these are pretty much same. For trihalomethanes also it is pretty much same. You can see uh, difference in density for some values. In organic carbon it is less, but the values that are above, for example here, in case of sulfate, in case of pH, in case of hardness, we can see some difference here. So this is how we can use SNS, the Simon library KDE plot, to understand the distribution of different parameters in one chart. So this is part 1 of water quality analysis project. In this part 1, we are doing this type of analysis where we have found the correlation between different variables, that is dependent variable analysis, and then we also are trying to find out distribution of features on the basis of potability 0 and 1. We will continue the discussion in the second part. Please follow the series, subscribe to our channel. If you have any doubts or suggestions, please ask them or share them in the comment section. Thanks once again.